Okay, geographers, this is your lab 6 for this week. This one's dealing with climate change, and you can see it ain't ours. It's one that has been borrowed to deal with this whole online situation. Some of these things we normally do, we can't do. This, I think, is an interesting thing to work through to learn about climate change and the greenhouse effect and the ozone layer and a lot of the stuff that we'll be covering in the lecture class currently, or you've already covered it in a past lecture class if you've taken it. All right. And so this, as you go through, it's similar to the ones that you've already been doing. This lab is set up so that you're supposed to work from start to the end. Don't jump around because it's trying to lead you through this and have you discover things as you work through. So if you haven't figured that out yet, with most of these labs, it can be a real pain if you are working out of order. Okay? Don't do that. Do yourself a favor, start at the beginning, work through, read slowly. Again, like with my own labs that I've given you, read through all this extra stuff, like the initial stuff here, because clues abound, right? It will help you figure out what these questions are quite often. Now, with this, as I've said with some of these other things, it's connected to what we're going to be talking about in class. Feel free, if any of this isn't making sense, work ahead. We're a little ahead of the lecture class right now, but you've got access to the climate change videos, those video lectures. I talk about the greenhouse effect, I talk about climate change, I talk about all of this stuff. And the ozone layer, which will be discussed at the end of this lab, I talk about that in the atmosphere lecture, when we talk about the ozonosphere and CFCs and all that stuff. All right, so I encourage you, if any of this stuff, if just the general concept seems vague, watch that stuff, read through the textbook, go online, do the Wikipedia thing, like whatever you need to do to have that baseline knowledge if this just isn't clicking. All right, but to help you out and help you get started, I will say with the greenhouse effect, and I'm going to define and going to clarify this stuff. What it's getting into, or what it's discussing here, is this layer of gases that exist and actually exist naturally speaking in the atmosphere. So these greenhouse gases are things like carbon dioxide, methane is another one. I can't remember if you've got a list of what these things are in here, but there's specific gases that deal with radiant energy differently from some other gases. Okay? And so the sun, as you've already heard me or some other professor talk about, the sun is sending out radiant energy, right? That's insolation, incoming solar radiation is coming down here to the planet, and it reaches us, relatively speaking, as shortwave radiation. Okay? And so wavelength just meaning how far apart two different wave crests are if you look at it. Okay? Don't worry about the real, like what that means and all that, but just know we have, relatively speaking, shortwave radiation coming to us. And some of that gets absorbed and upper reaches the atmosphere, but then other stuff comes right down here to the surface. Okay? That stuff that comes down to us, that solar energy that we're getting, we're going to use that. And I say we as the Earth, it could be us specifically, other organisms on the planet, bodies will absorb it, or surfaces or whatever, and just, that's how we're able to exist here, right? Because we're getting this heat, through this process of radiant energy coming down here, as well as other stuff. It's more complicated than that, but, just for what we're dealing with here, right? So we got the shortwave stuff coming down. Now, when it's absorbed down here, it's going to be converted into long wave energy. Okay, the wavelengths are going to stretch out, and then that energy, that long wave stuff, will be use, but then it will ultimately go back out into space. Okay, we're going to get rid of it. And so that's a thing to keep in mind. Energy coming in from the sun, we're going to take that down here, we're going to use it, but we also need to get rid of it. Because if we just kept taking in energy, this planet would have melted or exploded, billions of years ago. Like that just wouldn't work. So we take stuff in, we get rid of stuff, right? Now here's the deal. The greenhouse gases delay the release of this long wave energy. Okay, so the shortwave stuff comes down. When it gets converted into long wave stuff and it goes back out towards space, these greenhouse gases trap it, okay, hold on to it, and delay its ability to go back out into space. And as I said, this is a natural thing, and that's what the greenhouse effect is. It's the fact that we have these greenhouse gases, and therefore it keeps the planet warm, or warmer than it would be without the greenhouse gases. If we didn't have these to start with, we wouldn't be here, because all of this energy would just shoot back out into space. We could not survive. So we need greenhouse gases for life, for our kind of life, I should say, for us to be able to exist, right? So that's the greenhouse effect. Now the problem with this is that we have been adding to the greenhouse gases that are up there in the atmosphere, okay? CO2 is the big one that we talk about all the time, and that comes primarily from the burning of fossil fuels. So more CO2 goes up into the atmosphere, and what we're doing, effectively, we're thickening this layer of greenhouse gases, and it's like, I use the blanket analogy, where naturally speaking, before the Industrial Revolution and humans really took off changing the earth, we had a nice, thin, cozy blanket, like just enough to keep everything great, right? Just warm enough. Then with all our activity, so we've been putting more and more greenhouse gases into the atmosphere, we're making that blanket thicker, right? We're getting something bigger and thicker, and and maybe even that's like kind of nice in the winter, but you know what? In the summer, it's just too dang hot, right? That's the issue, right? And that's what's leading to global warming, which is leading to climate change. And we'll get into the distinctions of that in the lecture class itself. But that's why we're seeing increasing temperatures. It's because we have an increasing amount of greenhouse gases. Okay? So what this first thing is you're working through here and trying to figure out is getting a sense of what these greenhouse gases are doing, right? And a changing level. We have less greenhouse gases, more greenhouse gases. Okay? So it's really pretty straightforward stuff, but I know it can be daunting when you have like these wacky arrows going everywhere and new terms coming in. But just keep in mind what the greenhouse effect is, and think about that as you work through here, right? And a lot of these real straightforward, yes or no, right? So don't like stress out if it seems too simple. Other things you're going to have to explain stuff in here, like this, explain why it's incorrect. So you'll explain some of the stuff, but other things, you're simply circling things in here, right? So this is the whole greenhouse effect part. Then as you move on, it connects it to this concept of global warming. Again, I just explained how these things are connected, briefly. So between that and reading through here, I should be able to figure it out. More stuff on this, and you've got, as you go through here, it's kind of interesting how they have this set up. Like they have two students talking, and one of the students is brilliant and one is not so brilliant, is effectively what they're saying, and maybe that's a cruel way to say it. One student is just wrong, and the other one gets it, and you have to decide which one is the right one. This one is, you have a friend who says, and it's basically, I guess it's training you to, like, if you have like climate deniers or whatever, it's training you to shut them down, right? Or to maybe process some of these faulty arguments that come your way. Okay, so in your own words, do the best you can here and try to explain this stuff, or explain why this statement is wrong, or which of the statements is the correct one, or whatever. All right, and then at the end of this, you're going to connect it to the ozone hole. And the ozone layer, ozone is O3, right? So it's 3 atoms of oxygen stuck together. The oxygen we breathe from the atmosphere, it's O2. Okay, so that's great for us. O3 is actually toxic for us. We don't want to breathe that in. But up in the stratosphere, it's fantastic because it limits the amount of ultraviolet or UV radiation that comes down our way that can actually reach us, right? And ultraviolet radiation is just, it's more of that incoming solar radiation. So we get the visible light, right? What we think of as sunlight or sunshine. But ultraviolet radiation is also coming from the sun, but a portion of that is absorbed up in the ozonosphere, or what we call the ozone layer, right? So these ozone molecules are able to deal with UV radiation, and a lot of that doesn't come down here to get us. Some of it does, and we get into the full details in the lecture class, again in that atmosphere lecture. But so that's what the ozone layer is. Now in here, I'm trying to see, I don't even know. That's what happens when I don't use my own stuff. But the ozone hole, I'm not even going to get into it. But we have an area where the ozone layer is a lot thinner than it should naturally be. And that's also our doing. That's something else we screwed up with. And that's not pollution in the same sense of it. And this I want to stress that students quite often will confuse the ozone layer and the greenhouse effect and global warming and climate change and all this stuff. They kind of throw it all together. These are very separate, distinct things. And I was nervous to include this one here with the stuff you guys are working on, but it gets you to think about how these things are different. Okay, so I want to make that clear. But these CFCs, chlorofluorocarbons, are things we made. Long story short, they get up into the stratosphere, they destroy ozone, and then that lets more ultraviolet radiation come down here. So that's a problem. We don't want that because of sunburns and eye problems and skin cancer and all that stuff. But what this is going to get you thinking about is how ozone, like you can see this chart up here, ozone, greenhouse gas, the Earth's surface, how these things are affected by or affect visible light, infrared light. This is that the long wave stuff, and then ultraviolet, the UV radiation. Okay, so use that chart to make sense of this stuff. And then finally at the end, it gets into these students there. And those students, again, one of them's brilliant, one maybe not. This one thinking, I think the ozone hole affects the temperature because it lets in more UV light from the sun and warmer. And then student 2 is like, but UV light doesn't heat up Earth's atmosphere, so temperature's not affected by the ozone hole. Again, I want you guys to think about it, but you should agree with student 2. Okay, and I want to make that clear, again, because so often students conflate these things. All right, so hopefully this helps you get a sense of what it is you're doing. As always, you got a question, ask me about it. I'm happy to help. And so in the meantime, best of luck and have fun working on your labs.